I am going to work through the Chapter 7 Quest study guide. Feel free to pause, fast forward as much as you need. So, problem number 1, growth or decay. You invest money into a savings account that pays 6% annually. Key here is that if it invests money and you're paying, or the account is paying you 6% annually, that means the money in the savings account is going to grow. Number 2, you buy a brand new car which depreciates at 3.5% annually. Depreciates is like decrease in value, and so that is an example of exponential decay. Questions to go with number 3. Sketch the graph of each function. Use a table to determine your points. So, using the equation 4 times 2 to the x, this is where you can use the table function on the calculator, type in the y equals 4 times 2 to the x power, hit enter a bunch of times until you get to the table, and when you do that you can scroll a little bit, but choose values if you want to go from -3 to +3, -2 to +4. And so as you plug these in, you should get 1 for y, and then -1, 2, 0, 4, 1, 8, 2 is 16, 3 is 32, 4 is 64. So as I see my numbers, I would have liked to have chosen some smaller numbers here at -3 and -4 perhaps. So as I go to plot these on the graph, -2 goes with 1, -1, 2, 0, 4, the y-intercept is 4, 1, 8, 2, 16, and 3 is 32, which is well off the graph. So if we try -3, should get 0.5, and at -4 should get 0.25. And so remember, with exponential equations, these will not cross the x-axis. And so this is going to basically start as a horizontal line. It's going to be really close to the x-axis, and then we'll finally start to see it start to curve. And we just try and make it as smooth of a curve as we can as it's increasing exponentially. The second graph, we still have the same y-intercept. The a value is still 4, but now because the b value is 1/2, we're going to expect decay. So again, I'm going to try going from -2, -1, 0, 1, 2, 3, and 4. So when I put in -2, I'm going to get 16. -1 is 8, 0 goes with 4, 1, 2, 2, 1, 3 goes with 0.5, and 4 goes with 0.25. So when we go to plot these, -2, 16, then -1, 8, 0, 4 is the y-intercept, 1, 2, 2, 1, 3.5, 4.25, and again, it's not going to cross the x-axis, so we want to use this smooth curve as best we can here. It's going to end up going right above the x-axis looking like a horizontal line at the end. Right. Question number 4. Sketch the graph of each function, use a table to determine your points, then describe the transformation from f of x equals 4 to the x power for the first one, and f of x equals 2 to the x for the second one. So again, go to the table function, type in the equation 3 times 4 to the x power minus 1. Make sure the minus 1 is not part of the exponent. And then we're going to insert values in for x. Again, doesn't have to be these exact x values, but something around this range. So if I plug in -3, or read it off the table, I think I'm going to have to go to the calculator for this one. So I'm going to type in 3 times 4 to the -3rd power minus 1. So we get -0.95. Next number is a 3, so it will round down. Then I'm going to plug in -2 and get -0.8125. Put in -1. To get -0.25. Then we put in 0, 2. So normally 3 would be the y-intercept, but because we're subtracting 1 from that, that takes it down to 2. Next one is put in 1 and you get out 11. And 2 goes with 47, so that's getting really big. We'll calculate the last one just to fill in the table, but 191 is not going to fit on the graph. So as we go to fit these on the graph, okay. So at -3, 1, 2, 3, -0.95 is almost to -1. So because we subtracted 1 here, that's going to make the graph sort of shift down 1 unit. At -2, it's at -0.81. And -1, it's at -0.25. 0, 2, 1, 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, just off the graph. So, because of this -1, instead of not crossing the x-axis, it's not going to cross this line at -1. So we just follow that path to start with, and just try and get that curve to work. And so the transformation from the graph of y equals 4 to the x power to this one, first thing I notice is this 3 in front. Well, when my a value is 3, that's greater than 1, so that means I have a stretch by a factor of 3. And then the other thing that changed is this -1. And so when the k value is negative, that means it's going to shift horizontally. It's going to translate, sorry, not horizontally, it's translating vertically, going down 1 unit. So I'm going to add in here translation. No, I'm going to put vertical. vertical translation down 1, or down 1 unit. So we have a stretch by a factor of 3 and a vertical translation going down 1 unit. Right. Second graph, start out by making the table, -3 all the way to +3. And so when I plug in -3, -3 plus 3 is 0, 2 to the 0 power is 1. Again, use the table function on the calculator, enter the equation, hit enter a bunch of times to get the table figured out. So when I put in -1, get out 4, put in 0, 8, 16, 32, and 64. Once again, like in problem number 3, at -3 we're at 1, -2 is at 2, and so we're missing some of the graph in this case. 1, 2, 3, 4, 5, 6, 7, 8, and 16 goes off the graph. So if I put in -4, -5, I'm going to see this pattern continue here. So there's nothing being added or subtracted on the end, so again I'm right above the x-axis till it starts to curve to go up. So changing from the equation y equals 2 to the x to the equation y equals 2 to the x plus 3, the only thing that changed here is this h value. And so if it's x plus 3, that is going to be a translation, and because it's in the exponent, it's a horizontal translation. Because it's x plus 3, that's going to move it left 3 units. If it was x minus 3, it would go right 3 units. Right, so we'll flip over to the other side. So the first question on the back side uses a technique that we hadn't completely looked at. This kind of question is not going to show up on the test, but just to show one example of how this works. The property values in the Bay Ridge neighborhood are growing exponentially. They started at an average of $345,000 in 2010 and are now at $405,000 in 2018. What is the rate of growth? What will the average home price be in 2020? So the rate of growth comes from a formula that was on the back of a worksheet that we did the front side, but we did not do the back side. And so this r equals y to the 2 minus y to the 1 over y to the 1. So the rate of growth comes from the second y value minus the first y value. So in other words, the ending value minus the starting value divided by the starting value. So in this case, the ending value, the most recent price, is $405,000. And we want to subtract the starting price, $345,000. And then divide that by the starting price. Again, $345,000. So I take the calculator and type this in. So 405,000 minus 345,000 divided by 345,000. And this is 0.1739. So as a rate of growth, usually we think of moving the decimal 2 places over. So this would be the same as a growth rate of approximately 17%. So using that, what will the average home price be in 2020? So this is where we use the equation A of t equals the starting amount times 1 plus the rate of growth to the t power, number of years power. So if we want to find in 2020, that is 10 years after 2010. So our starting price was 345,000. We're trying to find out 10 years later. So we want to put 10 in for t. The starting amount was 345,000. And we found that the rate of growth, 0.1739, to the, and now the unit of time is 10, so to the 10th power. So we'll type that in, 345,000 times 1 plus 0.1739 to the 10th power. And so we find that after 10 years, the average home price will be approximately 1,714,661.42. So apparently Bay Ridge is a very expensive place to live. Okay. Now I used the whole decimal from the rate. So if I had instead used actually 0.1739 like I said I was, that would have changed it to 1,714,470.91. So by rounding this number off instead of using the full decimal from the rate, that changed my home price by almost $200. I would accept either form on this one. Alright, so that's if you don't have the percentage given to you. Number 6 and 7, this percentage is provided. Jess has saved $12,500 the first 5 years out of college. In 10 years, she wants to have enough money for a home down payment. The down payment is $30,000, but her family has offered to help her with half of it. If she invests her money in a 10-year certificate of deposit that makes 3.5% interest compounded quarterly, will she have enough for her half? So, because her family is offering to help her with half of it, that means she only needs half of it, 30,000. So if I take 30,000 and divide it by 2, that means that she needs 15,000. So far, she has 12,500. And so the question is, will she have 15,000 after this 10-year certificate of deposit? So we're trying to figure out, is the amount that she has in the account after 10 years enough with what she's already saved to make this $15,000 down payment. So we're going to start with $12,500, and the rate of increase is 3.5% interest. So we're going to change that into decimal form, and this is a 10-year certificate, so to the 10th power. Now, this phrase here, compounded quarterly, we're going to ignore that one. That will change the method just slightly, and so we're just going to use it in this form. Starting amount, rate of interest, number of years. So I'm going to type that into the calculator. 12,500 times 1 plus 0.035 to the 10th power. And so after 10 years, she will have $17,632.48. So will she have enough for her half? She needs 15,000, she will have 17,000. So the answer is yes. And I'll just add on, she has more than $15,000. Right. Number 7. If Joe's car is losing value at 9.6% a year, and he bought it new for $26,999, how much will it be worth as a trade-in on a new car in 4 years? So what will it be worth? So we're trying to find the amount that is worth 4 years from now. So the starting value is $26,999, but it is losing value at 9.6%. So we're not increasing, we're decreasing, and so we need to subtract 0.096. This is for 4 years, so we take it to the 4th power. Type this in the calculator, 26,999 times 1 minus 0.096 to the 4th power. So this will be worth $18,031.07. It's 0.065, and so the 5 rounds the 6 up to 0.07. Right. Logarithms. So to evaluate logarithms, this is where we rewrite these equations in exponential form. So we set these equal to x. The big number inside the logarithm just comes down as by itself. The base of the logarithm goes over to the other side, and what the logarithm equals, the x, becomes the exponent. Now I know 27 is a power of 3, and so I check the green sheet, check the exponent chart. I see 27 is 3 to the 3rd power. Because it's in the bottom of the fraction, it's 3 to the negative 3rd power. And so now that I have the bases are identical, that means the exponents have to be equal to each other also, and therefore x equals negative 3. Next one, bring down the big number, 64. 4 to the x power, so the base comes over to the other side. And so I notice that 64 is a power of 4. 64 is 4 to the third power. So now I have the bases the same, so that means 3 and x need to be equal to each other. X equals 3. Log of 2 with base 8. So I bring down the 2, the base goes to the other side, raised to the exponent of x. 2 and 8 I know are both powers of 2. So 2 is the same thing as 2 to the first power. 8 is 2 to the third power. And then I keep the x with it. The 2's are the same, so that means the exponents need to be the same. So when I divide by 3, x equals 1/3. Log with base 8 of 1/8. So I bring down the 1/8, 8 to the x power. So I know 1/8 and 8, they both have an 8 in them, so this 1/8 I can rewrite as 8 to the negative first power and keep 8 to the x. And so the only way these are equal is if x equals -1. Right, the next line. So rewrite, bring down the big 3, bring the base over to the other side. And so if 3 equals 3 to the x power, well, 3 is the same thing as 3 to the first power. So that means x equals 1. In the next one, bring down the 1. The base 4 is base of the exponential, x is the exponent. So this one's a little strange because 1 to some power is never going to be 4. But what you may remember is that you can get 1 as 4 to a specific exponent. And so this is where 4 to the 0 power equals 1. Therefore, the exponents have to be equal, so x equals 0. Log of 100,000. So what you have to remember on this one is that if there's no base written here, it means that there's a base of 10. And so 10 to what power equals 100,000? Well, 100,000 has 1, 2, 3, 4, 5 zeros, so it's 10 to the 5th power. And so if it's 10 to the 5th power equals 10 to the x power, that means that x has to equal 5. And the last logarithm here, bring down the 2,401, take the 49 over to the other side, raise to the x power. So, need my green sheet here. So 2,401 is 49 squared. So I can rewrite this as 49 to the 2nd power equals 49 to the x power. But if you don't, because that's not necessarily on the green sheet, and so another option here we could rewrite both of those as a power of 7. And so if we take 7, so another way to write this would be that 2,401 is 7 to the 4th power. and 49 is 7 to the second power. And so just sort of skipping this middle line, that if you recognize them both as powers of 7, then we end up with 4 equals 2x, which means x equals 2, which we saw back here on the 49 equals 49. Right, and the last section here, write as a single logarithm. So first step is to make sure there's no numbers in front of the log, so this 3 has to come back here as an exponent. So we get log of 4 minus log of 2 to the third power. Well, I know 2 to the third power is 8. And so when I subtract logarithms, that means I'm going to divide the first one divided by the second one. So log of 4 divided by 8, that's going to reduce to 1/2. So we end up with log of 1/2. The long one beside it, start out by moving the exponents. So the 2 comes back here with the r, the 3 goes back to the r, and we don't have to do anything with the next one. So we get log base 7 of r squared and log base 7 of r to the third power. And we keep the last one. So when you add these two together, they both have the same base of 7, but we're going to multiply r squared times r to the third. And when you multiply r squared times r to the third, it means that you add the exponents. So we're going to end up with log with base 7 of r to the fifth power minus log base 7 of n. So when you subtract logarithms, that means you're going to divide the first one divided by the second one. And so our final answer is log with base 7, the r to the fifth power goes on top, the n goes on the bottom. Right, and the last row, this 5 in front of the logarithm comes back and is multiplied by the 3. That you multiply the exponents together. And so that means 3 times 5 is 15. And now there's nothing else left to combine. So that one is finished. And the very last question, I'm going to bring the 2's back as exponents. So that's going to give me log with base 4 of 9 squared, log with base 4 of 3 squared. So 9 squared is 81, and 3 squared is 9. And so with subtraction, that means we want to divide so we keep the log with base 4, divide the 81 by the 9, and since that does divide, 81 divided by 9 is 9. I hope you were able to find some parts of this, at least, that were helpful to you. Please make sure that you are completing your assignments so that you are ready for the test on Friday. Good luck.